In example 3, we're going to try to determine, or we're try to evaluate from 0 to infinity of 1 over x squared plus 1 dx. So the first thing that I'm going to do is I'm going to switch that to the limit notation for an improper integral. So we have the limit as b approaches infinity from 0 to b of 1 over x squared plus 1 dx. Then I need to think about how I would integrate this. Well, it looks very much like an arctangent with this equal to u squared and this equal to a squared. So I'm going to use an arctangent integral. So at the limit as b approaches infinity, arctangent is 1 over a, which is going to be 1 over 1, arctangent of u, which is x, over a, which is 1, plus c. Now I'm going to go ahead and substitute in, oh, not plus c. What am I thinking? I have to do, it's definite, so I have to go from 0 to b. So now I'm going to substitute that in. So the limit as b approaches infinity of arctangent of b minus the arctangent of 0. All right, so I need to figure out what the I'm going to start by figuring out what I don't know why it keeps flipping. I'm going to figure out what the arctangent of 0 is. So I'm going to come over here to the unit circle. Okay. I know that arctangent has to be in quadrant 1 or 4. And I am looking for where basically the sine divided by the cosine is equal to 0. Well, I know that the only place that that can happen is here. And remember, it has to be a value between negative pi over 2 and pi over 2 in order to be true. So because 0 divided by 1 is 0, I know that that value there is 0 radians. It's also 2 pi, but in this case, we would use 0 radians, which means that this back piece evaluates to 0. Arctangent of b, limit as b approaches infinity. So now I'm ready to plug in my infinity. So I end up with arctangent of infinity. That's a little bit trickier. Really what I need to think about is what does the tangent look like and where does the tangent go to infinity? What values does that happen at? So I have Desmos here, and there is the tangent function. And basically what we need to find is what's happening. Where are these asymptotes happening that are between basically 0 and pi over 2 or pi over 2 or negative pi over 2. So I'm going to type in pi over 2 for kicks. That's what I'm going to type in x equals pi. And you'll notice that's not it, right? It's not an asymptote. So let's try dividing it by 2. There we go. So do we see how that value right there is definitely the pi is where the asymptotes are going to infinity, or where the functions are going to infinity. So that's our answer. Anytime you see arctangent of infinity, the answer is always pi over 2. And since we got a number, that means that this one converges. All right. Right tiny. Okay. I'm going to probably have to do some of my work off to the side. I did not leave you very much space for this. So right small. Using the Hopi rule with improper integrals, what's going to happen here? So I am actually going to probably start, I'll start here. We've got the limit as b approaches infinity from 1 to b of 1 minus x e to the negative x dx. It definitely looks like an integration by parts, right? So we're going to examine, seriously. All right, we're going to examine the LIATE, right? So there's no natural logs. There's no inverse trig, but there is algebra. So I'm going to use algebra to begin with. So this is the piece that's going to go into as my u. And it's your choice. You can do tabular if you'd like. I'm just going to do our normal u. So u equals 1 minus x. That means that du equals negative dx. It means that dv equals e to the negative x dx. That's going to give me a little mini u sub, right? So that means what I am missing here is a negative, right? So I need to make sure that negative is added in when I integrate my v. So when I integrate e to the x, I know I get e to the x, or e to the negative x, but with that negative right there. All right, so let's perform our integration here. And I'm going to go ahead and do it off to the side So again, I apologize for not giving you enough space. We're going to do the u, which is 1 minus x, v, which is negative e to the negative x, minus the integral of, it is negative e to the negative x times negative dx. Well, that double negative there is going to go positive. I do know I have this same u sub going on, right? So I would have to add in another negative before I integrate that. And then I'm going to kind of ignore it. Then it's going to go positive. So I've got negative 1 x, negative 1 minus x e to the negative x, plus when I integrate e to the negative x, I get e to the negative x. And then we're not going to worry. Technically, it's plus c. But in this case, we're going to kind of ignore the plus c part. I apologize for the screaming. All right, I'm going to go ahead and distribute this and this in. So we've got negative e to the negative x plus x e to the negative x, and then plus e to the negative x. Hopefully you're noticing that this and this are going to cancel. And all I'm left with is this, which I could rewrite as x over e to the x. So that's what I'm going to actually be finding the limit of. So I'm finding the limit as b approaches infinity of x e to the x from 1 to b. So that I basically did all the integration pieces over here to the side. I'm going to go ahead and substitute in. There's a very unhappy child downstairs. All right, we have b over e to the b minus 1 over e to the first. All right, and then I'm going to go ahead and substitute that infinity in. So we get infinity over e to the infinity minus 1 over e. And, oh, what happened? Something went wrong. B approaches infinity. Oh, okay. So what happened here, I should have split this into two. I apologize. I'm going to find these two limits separately. So I'm going to find the limit as b approaches infinity of b over e to the b minus the limit as b approaches infinity of 1 over e. Well, this one here in the back is just 1 over e. But this piece here, if I put infinity in, it would be infinity over e to the infinity, which is infinity over the infinity, which is indeterminate. Okay, which means I have to do L'Hopital's rule. So we do L'Hopital. Okay, so we really have the limit as b approaches infinity. Derivative of the top is just 1. Derivative of the bottom is e to the b. Now I'm going to put in infinity. So 1 over e to the infinity. And then that was a small number over a giant number is going to be 0, which means I'm just going to get negative 1 over e.